Hello and welcome. I hope you're having a great reInvent. If you're here, it's because you use AWS. And if you use AWS, it's almost guaranteed that at some point, sooner or later, you'll be storing your data on S3. S3 is a flexible, scalable object storage for the cloud. And once you start putting data in the cloud, it becomes extremely important to secure that data, making sure that the right people have access and nobody else. We at AWS deeply understand having security as a top priority because we think about it that way too. I'm Meg, later you'll hear from Becky. We both work on S3 and this is what we think about every day. Since S3 is so ubiquitous across AWS, it's worth acknowledging that there are different sorts of workloads. They're different and they have different security objectives. S3's extreme scalability, availability, and durability make it a great place to store your data lake. Storing your business's data lake on S3 allows you to use analytic and machine learning workloads, both from our service offerings, partner service offerings, and your own workloads that allow you to unlock ever more value out of S3. So that's probably one way that you're using S3. You also might be storing all your log data for future analysis. S3, as a highly available object store, is a great place for you to store infrastructure data, like your configuration files that make your applications work. And finally, and this is one of our flagship use cases, you're probably using S3 to store your content for your customers, like media content or things that make your website work, like the JavaScript and the HTML. And who needs to access this data? Certainly human users, like the data scientists interacting with your data lake and the consumers of your website. And this little red worker hat that you see here, we're going to use it throughout the presentation. It represents AWS's identity system, identity and access management. These roles need to access your data as well, both to produce and consume data. And your whole job here is securing this data, no matter what the workload is and no matter what your requirements are. And so we know, as you start to research, how do I secure my data in S3, there's a lot of advice and chatter out there, so much so that it might seem complicated. It's not. When we were preparing for this talk, we thought about the tactics that our customers use to successfully secure their data, and we boiled it down to 4 tactics, or what we're going to call right answers. So this talk is going to be played in 4 acts. We're going to give you all the practical advice that you need to implement these tactics, and that'll be straightforward. But because this is a deep dive talk, we're also going to talk a little bit about the how and the why for each of these. So let's get into what these right answers are. Our first right answer is S3 block public access. This is the most important of our right answers because it prevents your data from being accidentally made publicly available. Next, we're going to talk about default encryption, a little bit about how to choose the mode that's right for your business, and about how it works under the hood for those of you who are interested. All services in AWS are protected by means of IAM, which again is our Identity and Access Management System policies, and S3 is no exception to that. We're going to spend some time talking about how to write good policies and what we think the best ones for S3 are. And finally, we're going to introduce you to our newest security feature, the ability to disable S3 access control lists on both new and existing buckets. This is a less is more feature that allows you to scope down your access and audit control strategies to the S3 bucket policy. We strongly believe that the right path forward for nearly all modern workloads is to disable these S3 access control lists. So let's get into it. As I said before, block public access is the most important thing. If you take nothing else away from this talk, you need to go home and turn on block public access. So what's the first thing that you do when you want to use S3? Well, you create a bucket. And like all other resources, which means things that you own in AWS, the bucket, when you create it, is owned by the account that created it. And no entities outside that account can access the bucket. It is private by default. Of course, there are ways that you can grant access to the data to your bucket to other accounts for read, write, or both. And in a large enterprise environment, you'll be doing that a lot. But until you take that explicit answer, this bucket is private. All right, so let's talk a little bit about what we mean when we say entities within or without the account. Again, AWS's identity system is identity and access management. And identities are called IAM principals. Becky's going to talk a lot about what principals are, but they represent users. IAM, in fact, has users, but most modern workloads use the IAM role, which is an identity associated with temporary signing credentials. IAM roles use these credentials to sign requests to all AWS APIs. That includes the S3 API, and these are authenticated requests. So here I'm showing you 3 roles that are within the same account that created the bucket. So they're in the account, and the bucket's private by default. So do they have access to the data in the bucket? Actually, no. All IAM roles have policies attached to them that say what they can do. So they might have access if the policy says that they have access. Otherwise, they don't. But you know who definitely doesn't have access? Anyone outside the account. This includes anonymous users or an IAM role in another account. No matter what policy they have over in their account, unless there's a policy in your account that says they can access your data, they cannot. And block public access is a dead simple feature by which you declare that under no circumstances should data in this bucket be accidentally made publicly available. And what that means is unless you grant specific access to a specific entity, no one will be able to access your data. Now, does that mean that you can't share data? Of course not. This is a particularly powerful feature because it's not a hammer that locks data inside your account, but rather it's targeted at preventing accidental exposure. And in fact, we've made this even easier. You can enable this at the account level. When you do that, it impacts your existing buckets and any future ones that you might create. It's a set and forget with no additional configuration required. And so that's all you need to know. Go home from reInvent, look at all of your accounts, make sure block public access is on. If it's not, and your data is not intended to be publicly available, which it most likely is not, turn it on. But when you go to turn it on, you're going to see that there are 4 subsettings. And because this is a deep dive session, we're going to talk about these, even though all you really need to know is that they all should be on. There are really 2 sets. And the first 2 I'm showing here, block public ACLs and block public policy, concern any new policy or ACL that you might place on your bucket or somebody in your account. An ACL is an older means of sharing data that we're going to speak about in our 4th right answer. Block public access is a simple feature for our customers, but it's powered by our automated reasoning, which applies mathematical techniques to prove whether a proposed policy is public or not. If it determines that the policy is public, or if you try to create a public ACL, you won't be able to. You're just going to get an access denied. The second set of configurations here, ignore public ACLs and restrict public buckets, concern configurations that already existed when you turn on block public access. Again, our automated reasoning is going to do the same mathematical techniques on the policies, determine if it's public or not. If it determines that it's public, it's going to scope this policy back down to within your account. Public ACLs will be ignored. So that's how it works, but remember your job is to turn it on. So let's talk about some scenarios for S3 block public access. Show of hands, who thinks block public access is a good fit for data lake buckets? All right, nice, those of you who put up your hands, that's correct. People need access to your data lake buckets, your content creators, your data scientists, but they're going to have policies that allow them to access your data. All right, raise your hand again. What about buckets containing application configurations? All right, thank you. That's correct. Again, your workloads need access to this data, but they are IAM roles. Log data? All right, thank you, everybody. That's right. And again, the applications that are creating these log data will have the policies that allow them to write to your bucket. All right, so let's get a little trickier here. Who thinks this is appropriate for a static website? I see some shaking, but good job, those of you who raise your hand. This is actually a great case for block public access because the best way to deliver your website in the modern era is to put a content delivery network in front of it. You can use ours, CloudFront, and this is great because it gives you edge caching and low latency for your customers, and more importantly, you configure your bucket as a specific origin for CloudFront. So this is not accidentally public data. This is data that's being intentionally shared with an AWS service. All right, and lastly, what about public data sets that you intend to make directly available from S3? Is this a good case for block public access? All All right, good. No, this is not. And these use cases are rare and would encourage you to think about whether this is something that you really need to do. But if you determine that your business requirements require you to make data sets directly available from S3, what we suggest is you sequester those into their own account. Leave that, open to the public, and all other accounts in your ecosystem enable block public access. All right, so let's move on to our second right answer, encryption. When we talk about encryption, what do we even mean? Well, first, you can encrypt client-side before you send your data to S3. We provide an encryption SDK for you to do this, or you can use your own applications. Your data is encrypted in transit. And finally, we provide several modes to encrypt your data at rest. The focus of this talk is going to be on the encryption at rest options. And we're going to start by taking a look at some of the modes that our customers most commonly use. We're going to look at it through a couple lenses. Your ability to manage any key policies on the root key that provides the key material for encrypting your data, any additional visibility you get into AWS CloudTrail logs, your ability to control the root key rotation, and any impact, if any, on data shareability. The most common encryption mode that our customers use is called SSE S3. This stands for Server-Side Encryption S3. In this mode, S3 controls the root keys and manages them on behalf of our customers. There are no key policies to manage. You don't get any additional visibility in your CloudTrail logs. S3 handles the key rotation, and there's no impact on data shareability. This is a common encryption mode chosen by our customers because it provides the encryption at rest that they require, and it's free. The next most common mode is using SSE KMS with a customer-managed root key. KMS stands for our Key Management System. This is a across AWS service where customers can own their own keys and use it to encrypt data across S3. When you use SSE KMS, you control the key policies. We're going to talk a lot about what policies are, but here this means that you can control who can encrypt and decrypt data as well as other actions. You get visibility in your CloudTrail log, so anytime somebody's an account, an IAM role, accesses your key, that's logged in CloudTrail. You control the key rotation, so if your business requirements require you to rotate keys on a regular schedule, you're in charge of setting that up here. And there's no impact on data shareability because you're able to write key policies that say who can do what with your key. Finally, some customers choose to use SSE KMS, but with an AWS managed key. Now, there are some important callouts here. When AWS manages the key for you, you cannot write any key policies. You still get your visibility in the CloudTrail logs, which tells you, when that key was used. AWS handles the rotation, but most importantly, because you can't write those key policies, you cannot share your data outside your account. So if there is any reason why you think in the future you might want to share data and you want to use our key management system, KMS, then you should go ahead and create a customer managed key. So you know that you want to encrypt your data. You've chosen the mode that meets your business requirements. How do we go about doing that? Well, you can add headers at the object level. And so this is the header that tells S3 to encrypt my data with SSE S3. And these are the headers that tell you to do that with KMS. So KMS, and then we specify the key that you want used. Now you might be saying, I'm all bought into encryption. I know I need to encrypt my data, but I'm not changing my workloads to do this. I've invested a lot of time in making my workloads the way that they are, and I'm not touching them. In that case, you'll want to enable S3 default encryption. This is a one-time bucket level setting that automatically encrypts all new objects coming into your bucket. You specify the key type that you want, so again, SSE S3 or SSE KMS. If you choose KMS, then you specify a key, and again, using your own or service managed key. And remember, using that service managed key, while you don't have to deal with the rotation or managing key policies, that comes with a limitation on not being able to share your data. And finally, if you choose KMS, we suggest that you enable bucket key. This is a feature that we're going to talk about in a couple minutes. But first, we're going to take a quick quiz. So if the object put has no encryption specified in the headers, and the bucket has SSE default enabled, raise your hand if you think we're going to get no encryption. All right, are we going to get SSE and S3 encryption? All right, thank you. For those of you who are playing along, we're going to get SSE S3. Let's flip that. The put's telling us SSE KMS, it's giving us the key to use, but the bucket has no default encryption. Raise your hand if you think we're going to get SSE KMS. And raise your hand if you think we're going to get no encryption. Perfect, SSE KMS. We're gonna get a little tricky here. Now we have an object where the header in the put says SSE S3, but the bucket has been configured to be SSE KMS default. Perhaps this business has a requirement to control their own keys. Raise your hand if you think we're gonna get SSE S3. And raise your hand if you think we're gonna get SSE KMS. All right, I'm gonna make a lot of you mad because we're gonna get SSE S3. S3 respects what the object says. But you might be saying, okay, hold on. My business needs to manage my own keys. How do I make sure that happens? I don't want anybody writing to my bucket with SSE S3. The answer to that is you use a policy. And again, we're going to be talking about policies in much more detail soon, but this is a sample policy that denies any put that is not KMS. And you can go further and specify the specific key that you want in the case that it's important that a particular bucket uses a particular key that your enterprise owns. All right, so we've talked about the encryption modes. It's important to enable it, pick the right one for your business, but we're gonna talk a little bit about how it works in S3. These examples will be KMS, but the way that the encryption works and how we store the keys is the same for SSE S3. So in this case, a customer issues a put request and either the header says KMS or the bucket is KMS default enabled and there's a key specified. S3 requests that KMS sends us a data key to use to encrypt the object. KMS validates that this customer has the permissions to encrypt objects and sends us back a plain text data key. S3 uses that to encrypt your object. KMS also sends an encrypted version of that key to S3, which we store alongside your object, and we destroy that plain text data key. When the customer goes to read this object, they send a GET request to S3. S3 sees that this object is KMS encrypted and sends that encrypted data key to KMS. KMS again confirms that this customer is able to decrypt objects, and if so, sends us back the plain text data key. S3 uses that to decrypt the object, and we send the plain text bytes back to the customer, and we destroy that plain text data key. Now, I mentioned a feature called bucket keys that those of you who use KMS should be very interested in. This was a feature that we launched in 2020 designed to increase the performance for encryption and, perhaps more importantly, reduce costs for those of you who choose to use SSE KMS. We've seen customers get cost reductions up to 99%, so definitely something you want to pay attention to. So let's look at how it works. The first request is going to look fairly similar to a vanilla KMS request. The customer sends us a put request. They say it needs to be KMS encrypted. We go ask KMS, can we use your key? KMS sends us a key back that is now a bucket key. S3 uses that bucket key to derive a unique plain text data key, which we use to encrypt the object. And we store an encrypted version of that bucket key alongside your object in your bucket. And again, like always, we're destroying this plain text data key. Now, what makes bucket key special is on the next request, the customer sends us a put request, and we see that it's KMS encrypted. We go to their bucket key, we validate that they have the permissions to use this key. The key is time limited within S3, and if so, we generate a plain text data key. We use that to encrypt the object again, durably storing it in your bucket and destroying that plain text data key. But the most important thing here is that we did not need to call KMS. This is how we've improved performance and reduced your costs. I'm going to hand it over to Becky now to talk about writing some policies.
All right, well, welcome. We're at our third right answer here. And of course, if you're at a talk about security in the anything in AWS, of course, we're going to be talking about identity and access management policies, learning how to read good policies, learning how to write good policies. Actually, even ignoring S3 for a moment, this here, re:Invent, this is a learning conference, and people often ask me, I'm a builder, I'm going to be using AWS. What do I learn? What should I focus on learning? Because there's so much. What should I focus on learning to become really effective? And my answer is identity and access management, IAM. Get good at these policies. It's a really, really useful cloud skill. It's actually not as hard as many people think. Well, so S3 permissions are controlled by IAM, just like every other AWS service. So I'm going to start a little bit, but there are some techniques that are particularly useful with your buckets of data in S3. So I'm going to give you I'm going to sort of start by talking about a little bit about how this works, just for those of you who are not familiar with it. And then we're going to get into some common use cases, things that things that we see a lot of customers asserting on their buckets in order to provide the sort of security that they want. So start at the beginning. S3 actually existed before identity and access management. S3 was kind of the OG AWS service, just celebrated its 15th birthday. And yeah, it was storage for the internet. That's how we build it. Over here you can see something, it kind of looks like a file system, even though actually S3 is an object store. It's not a file system. The only thing it has in common with the file system is that there are slash characters. But you might organize your data using those slash characters to look like folders and files, and this data, the storage for the internet, right? Kind of two sorts of categories of use cases for this. One is access from AWS accounts, those that own the bucket, maybe other AWS accounts, as well as, one of the original use cases in S3 was kind of directly hosting a static website out of S3. And so you'd have like anonymous users on the internet just making HTTP gets to S3 to get your data out of the bucket. So again, in the era before IAM, S3 had a permission system. It was access control lists, ACLs, and they kind of resemble the ACLs that you might see in a file system, though once again, S3 is not a file system. And you'd have ACLs on the bucket, ACLs on the object. This was the original permission system. Fast forward to today, 2021, this is not how you do security in S3 anymore. The way you do security in S3, the way you do access management in S3 today is with policies. We're going to come back to these ACLs in just a little bit, but let's go on to policies. All of your tactics should be focused on IAM policies, both the positive cases where you want to share data and the negative cases where you want to assert that certain patterns of access cannot happen. But first, let's talk about what these policies are and how they do, and how they work. IAM, well, in IAM, you have principals. Those are the identities in the IAM system. You have actions that they take. In S3, if you're reading an object, the action is called getObject. And then you have the resource, kind of in grammatical terms, the direct object of the sentence, what they're acting on. And in S3, you could be acting on the bucket for some actions, if you're like listing out the contents. You could be acting on the objects for other types of things, like I'm reading a particular object. And so, when an IAM principal makes a request to any AWS service, including S3, it's signed using a technique called SIGV4. We document how this works, but you don't really need to know how to do that, because all of our SDKs and our console and our command line interface, they're all kind of doing that for you under the hood. But you can kind of look at what they're doing. They sign it. The service, S3, first authenticates it, make sure that whoever's asking, with the signature, make sure whoever's asking is who they say they are. And then they figure out whether, they do authorization. They figure out whether this entity actually has access to do the thing that they were trying to do. So over here I have an IAM principal. Let's say everything that you're looking at is all in the same account. I've got an IAM principal. They have a policy associated with them with a statement like the one that you see here. Allow and deny are sort of the two verdicts here. Allow this action getObject, let them read objects on, you'll notice that the resource has a wildcard in it, and all of our services support that. So basically I've said this is the ARN, the Amazon resource name. These are fully qualified identifiers. The resource you're seeing here is, basically I'm saying anything in my bucket under path/to/anything. This identity should be able to read it. So this identity here is trying to read path/to/object, and they're going to be able to do it because the request they're making matches that statement in the policy. It says allow. I don't see any other statements denying it, and so they get access to do that. And basically, if you understand how that works, you basically know how to write an IAM policy at this point. So for example, if this principle is like an application, let's say that instead of calling getObject to read an object, or maybe in addition, they also need to list the objects in a bucket. They need to do a listing of the objects in the bucket. So what would I say here? What am I allowing here? Well, the answer to that is, the verb is different, the action is different. It's called list bucket. The target of that, the resource involved, is also different. It's a bucket. It's not an object. So that's the ARN of the resource. And really, it's kind of rinse and repeat for any action that you're trying to configure permissions for. I've got a QR code up here. This is my favorite page of the AWS documentation. What this is this is the IAM resources and actions page. If you look at the left rail of that page, there is a list of every AWS service that exists. And for every AWS service, including S3, there's a table there. The table catalogs the actions that are available for you to take in that service and the resources that each action involves, as well as a bunch of different, we're going to see conditions later, a bunch of different conditions that are relevant to such an action. So that's how you don't need to memorize any of this. You just need to know how to, the pattern. You need to go to look at that table, what action am I taking, what resource, and then you can write a least privilege permission to anything. And this is how you do common things in S3. Now, we'll go back to right answer number 2. Let's say you're doing encryption, right? Let's say you're using server-side encryption with KMS, SSE KMS. Okay, let's talk about what happens with policy here. So I've got this bucket, it's full of objects, they've been server-side encrypted with KMS. This is fantastic because I get all the power and control of KMS, but I don't have to do any crypto choreography over on my side because that's all done on the S3 side. So I'm asking to read an object. It's encrypted, but I'd like to read it. Well, we already talked about how I get to read the bits of the object, get object. So I'm going to write that in my permission. So what's going to happen here? How's this going to go? How's this going to go for me? Yeah, it's not going to go so good yet, right? Because the thing is, when I'm reading an object that is SSE KMS encrypted, well, certainly I need permission to get object of the object, but I'm not done here, right? There's another AWS resource in play here, and that's the KMS key, the CMK, the customer managed key here. So that's an AWS resource. It's a different action. It's a decrypt action. I need permission to that as well. This is sort of a compound action now. So in addition to this policy statement that I need, because I need access to the object in S3, I have that permission, don't yet have this permission. How do I fix it? Well, I fix it by adding a policy statement. So again, it's a compound action. Now I have permission to read the bits and decrypt the bits, which is an S3 needs to assert both permissions in order to give me back the clear text of the object that I wrote. So this is just, I mean, what I've told you is not anything specific to S3 or KMS or anything like this. This is just the pattern to look out for. You know, if you understand the mechanics here, you really do kind of know what you're doing. So everything I just told you is all what goes on within for access within a single account. In S3, in a modern AWS environment, probably most of you are working in environments, I would guess, that have multiple AWS accounts. So depending on the size of your organization, you might have a few, and you might have a couple thousand. Now, becomes very common, particularly like if you're thinking about a data lake, right? A large set of data that you have a constellation of applications around extracting value out of it in one way or another. You're probably going to wind up in a situation where you need to make your data accessible outside the account. Meg talked a little bit about this in block public access. You'd have block public access on this bucket, but you do have specific sharing scenarios. And for those, right answer number 3 says focus on the bucket policy to make those happen. So I'm going to show you exactly how you do that. Because there is one more thing going on here when you're making requests cross account. So suppose I have AWS account 1 and AWS account 4. AWS account 4 owns the data. AWS account 1 has some workload in it that needs access to the data. Okay, well, in AWS account 1, we already know how to do this. So let me write this policy here, get object. They can get, let's say, I want them to get all the objects in, I want them to have permission to get all the objects in the bucket. So I write that policy statement, totally works. Now, what happens here? What should happen here? Right, see a thumbs down, exactly. Right, think about what should happen here. If you should not be able to walk into the locksmith and request a key to my house, right? Because it's my house, and I had nothing to say about that, right? So if somebody owns data, they need to be able, that bucket is private by default. Account 4 needs to say something about account 1 having access before account 1 can do anything to have access. Account 1's already doing the right thing. They've granted themselves permission to read the bucket. But until account 4 says this is okay, this shouldn't work, and it doesn't. S3 buckets support a policy that's on the bucket. So in IAM, you see policies attached to a number of places. So we were looking at the policies attached to the principal. It says what the principal can do. Right now you're looking at an S3 bucket policy. That's what we call a resource policy. It's a policy attached to a resource, to a thing that says who can do what to it. Just as a by the by, there are a number of other policies you'll see around AWS. When working with S3, you'll often be using a VPC endpoint to S3. That too has a policy. If you're working with AWS organizations, you also have the ability to assert policies at the organization level and a service control policy. These are all different places you can put policies. In this picture, because we have two accounts involved, the principal's in one account and the resource in the other account, each of these authorities has to say that this access is okay. So on the S3 bucket, over here, we have this statement here, and it says that, you'll notice there's this other thing, principal, because it's the resource. It has to talk about who. The principal didn't have to talk about who, because we know who. The bucket is saying, account 1 can read my data. So now we have the permission on both sides, so this is going to work now. So this is how sharing works. Whenever you're sharing data outside your account, you're probably going to find yourself writing a policy that looks kind of like what you're looking at here. At AWS, we love scale. Let's scale that up. Let's have 6 accounts that need to read the bucket. You know what? Let's have 4,000 accounts that need to read the bucket. And typically, if you're working in an at a company that has lots of AWS accounts, they'll be grouped together under sort of this payer structure called an AWS organization. AWS organization both groups everything under a single payer and gives you a lot of integrations all around AWS, and as well as security controls across the whole thing. Now, AWS Organizations is very deeply integrated with identity and access management, and in particular, in the realm of sharing data, it gives you some pretty useful scalability tools. So I've got 4,000 accounts. They're all in the organization. I've got this central bucket. Maybe it contains like the shared config for all of the applications, so it's important to me to have that be readable inside all within my organization. So I might write a bucket policy like this. Maybe the bucket needs to be readable and listable, so I'll make my policy look this way. And instead of talking about an account, I talk about a particular principal org ID. Now, those of you who are used to reading IAM policies, you might be looking at the first 2 lines of that statement. It's like, oh, she's saying allowed to everybody. But you'll want to look down a little bit further. This is where block public access helps you. That principal org ID condition, in order for a statement to match, like everything in the statement needs to match the request that's being made. So it's saying allow everybody so long as they come from the right organization. So this is doing what I want. This is a good least privilege policy for what I'm trying to express, which is that I want this bucket to be accessible everywhere across the organization. Now, of course, to get a little bit more granular than that, maybe I don't want the bucket policy to be accessible to everybody or every part of it to be accessible to everybody. Maybe this bucket contains lots of diverse data sets, and I have specific discrete use cases, right? Maybe account 1 should have read access to everything. Maybe accounts 2 and account 3, maybe they should have read-write access. They should both be able to read all the data in there as well as write data. Maybe they have different paths. Maybe account 1 is for the red data set and account 2 and 3 are for the blue data set, and. Now, if you see yourself starting to write a bucket policy like this that basically conceptually is a set of discrete use cases like one after the other, one thing that can really help with the manageability of such a thing, because these things can get long, and there is a limit. These things can get long. They can get hard to manage. You know, think about just silly things like if somebody goes and edits it and somebody else is editing and overwriting and all kinds of scenarios like that. If you have a bucket policy that's starting to take this shape, I would look at a feature of S3 called S3 Access Points. This is not a brand new feature, but it's a relatively new feature of S3. It is basically gives you sort of, on a conceptual level, it gives you alternative endpoints to the bucket, where you can tailor each endpoint to a specific use case and then just give different sets of clients these different endpoints to your bucket. So over here, I have 3 projects that need to access the data in my bucket, although I could have many more than that. I have the red project, the blue project, the yellow project. Each of them should have access to a slightly different part of this bucket. And each of them has a set of accounts that operate in that project that we should give them access to. So I could write a massive bucket policy, but this is actually cleaner. So this is a really clean way to share data that's in a pattern like this. The red accounts get to the red project, the blue accounts get to the blue project, the yellow accounts get to the yellow project. And one really neat feature of this is a pretty new feature. We launched this over last summer. When you create an access point to S3, S3 will assign it a name, like a string, that works and quacks like a bucket name. So basically you can take that, if the blue project is trying to read data from this bucket by way of this blue access point that has exactly the policy that's relevant to the blue access point, what it can do is it can actually use that for the bucket name. You can use this S3 assign. So then your application doesn't really need any major changes. It just needs to be pointing itself to a different bucket. Right? So each of these access points has their own discrete policy. They can be added and removed on a one-by-one basis. It really makes manageability of these kinds of use cases easier. So bucket policies, if you're sharing data, you're writing a specific bucket policy to share your data. I'm not going to give you the flip side of that because this is where the real power of IAM, and particularly as applied to an S3 bucket, comes in. This is also a very effective way to exclude the access patterns that you don't expect. So here's a bucket I have of data, and let's just think in very general terms, and I'm sure this is probably everybody in this room is going to relate to this. Who needs access to the data? Well, one or more AWS accounts that I know about need access to the data. They're probably in my organization. Maybe even some specific partner accounts. So I know exactly who they are. They should have access to my data. Who else? Well, if you use enough services in AWS, you're going to encounter quite a few use cases where an AWS service itself needs access to your bucket. Sometimes to read, most often to write. Like if you think about our CloudTrail service, when you set up CloudTrail, you give it an S3 bucket, right? And CloudTrail is going to go deposit all of your CloudTrail log events into your S3 bucket, ditto VPC flow logs, ditto GuardDuty findings exports, right? There's a whole long list of services that want to interact with your S3 bucket. And of course, these are use cases you don't want to exclude. These are use cases you want as well. But I can basically draw a circle around that and say, or an ellipse. I can draw an ellipse around that and say, that's what I want, to the exclusion of everything else. Everything I didn't say is going to access my bucket. I really just don't want that to be possible, no matter what other kinds of configurations might be in play. And bucket policy also gives you a way to do that. So I'm going to show you a couple of use cases that we see, customers who are defending their data. These are just some very common patterns that we see that might be applicable to something you're trying to express on your bucket. All right, this is a kind of long bucket policy statement. Don't worry, I'm going to read it to you step by step. The one thing you need to know about reading IAM policy is when a request gets authorized, basically the IAM system pulls in all of the policies that are relevant, principal policies, resource policies, maybe VPC policies. Basically what it does is these policies are all consist of multiple policy statements. For each statement, it either matches the properties of the request or it doesn't. So we take away the ones that don't match the properties of the request, and for the ones that do match the properties of the request, I've got to see at least one allow, and I can't see any denies. And then the request is allowed through. So here you're looking at just one compound statement. In order for the statement to match, everything in the statement has to match. So you're looking at one compound statement, and I sort of mentioned in the comment, there's other statements here that allow access. This one's a deny, so it doesn't grant anybody access. It just says what can't happen. So over here, let's read this one. So it says, we'll read the top of this. We're saying we're going to deny access to everybody who takes any action on this bucket or its objects. Let's go through these conditions, because it's a little bit of a double negative here. So the first one says, we saw principal org ID before. We say, okay, we're trying to deny this if the caller is not one of mine, right, not someone from my organization, and if the caller is not an AWS service, right, because that was another thing that is sort of expected for our buckets. Now, I haven't granted access to any AWS service on this bucket. That would come in the other statements. But I might append this statement to any policy so that I can assert that no matter what else it says, it better be an AWS service or it better be one of mine. Otherwise, I want to block the access. Now, by the way, this principle is AWS service. This is a relatively new IAM condition key launched a few months ago by the IAM team. And it is specifically for these kinds of use cases where you're trying to make these broad assertions. Everything outside my bubble isn't happening. So the principle is AWS service is a really good shorthand to be able to group together like, yeah, I'm generally expecting AWS to interact with my buckets, when I specifically allow it. So this is your good sort of scalable simplifier for being able to say that. Let's talk about another use case, network location, right? Now, I should mention, in a modern sort of zero trust approach to security, you never want to use network as a reason to grant access. Like, just because you're in the right network does not mean you should get access to something. Access should always be done on an authenticated and authorized basis. You should have an identity, and that identity should have permission to do the thing. But you should never grant access, but it is a very useful secondary signal, because you often do know the network locations from which your data is supposed to be accessed, and you kind of want to exclude everything else, right? Because that's unexpected. So in a typical, enterprise environment, I might have some VPCs, some virtual private clouds, my network in AWS, from which I'm running all kinds of workloads, and I'm expecting those to access the data. I may also have a data center that, that my people are working in and, connected to AWS, reading the data. And I know exactly where on the internet my data center employees are going to be reaching S3 from. And basically, I want to say if it's not one of those, they're not coming from one of those networks, I want to exclude it. I haven't granted anybody access, but I know what I don't want. Okay, so we got another one of these compound policies. Let's read this one. Okay, we're going to deny access to everybody who takes any action on the objects of my bucket. By the way, you notice that I'm specific about the objects of the bucket here because it's generally the data access that you care about. You want to be careful with policies like this that you don't accidentally lock yourself out of being able to make the necessary changes to the bucket itself. But here I'm saying, okay, you can't read the content, read or write, take any action on the contents of any of these objects. All right, let's look at these conditions. The first one says, it doesn't come from my VPC. Now this source VPC condition, this is something we've had for quite some time. It goes with a construct called VPC endpoints. In modern use of S3 from your VPC, you'll probably be setting up a VPC endpoint to S3 because it gives you this nice scalable property where it will basically identify requests that took that network path, and you can say these are expected. I'm not going to exclude them. And it's not from my on-premises network because I know where those are, and those are not unexpected. And finally, right, this is where you kind of account for the other use cases. Well, think about all the CloudTrails of the world accessing my bucket. They're not from either of these networks. They're from Amazon somewhere. But nonetheless, they're not unexpected. They're wanted often. So when it's not an AWS service and when it's not this other thing via AWS service, this was another IAM condition that we launched this year. Again, one of these scalable simplifiers to account for use cases. We have use cases in AWS, maybe you've seen them, where you make a request to one service. As an example, like AWS Athena, you're making a query against your data in S3, and that service, Athena, makes an onward request to S3 on your behalf, under your privileges, to read the data in S3. Well, that second hop, also not from your network, so this scaler kind of helps with that. Like, that's not unexpected either. And so this is the policy that says that, this is the policy on my bucket that says, if they're accessing the data in my bucket, it's from one of these networks that I was expecting. So I just showed you kind of two perimeter use cases where we didn't share data in any way. We assumed that there's other statements doing that. But we made some assertions that said no matter what else is going on in this bucket, these things are true. Here you're looking at one that prevents the request from coming from an unexpected network, and previously you were looking at a statement that prevented the access from unexpected identities. Now that brings us to our fourth right answer, which I'm really excited to talk about here today because this is our newest security feature in S3. We announced it just this week, the ability to disable ACLs on an S3 bucket. Now we think this is a really big simplifier, and like the other right answers we talked about, really the takeaway here, the 411 on this is disable ACLs, like this is something you should go home and do. But again, we're gonna go a little bit under the hood. That's all you really need to know to be strictly effective. But I'm gonna go a little bit under the hood and explain kind of what ACLs did and why disabling ACLs is such a simplifier, why we're telling you to do this. And disabling ACLs means that then your entire focus is on the policy, the techniques you just learned, in order to get security right in S3. So let's consider a scenario here. The blue account has a bucket in it. And there's a number of other accounts in my world, red, yellow, green, and some of them should have access to this bucket. In fact, I think what I want to say is that some of them should have both read and write access. Maybe this is a rendezvous point for data. Readers and writers should be able to sort of access this shared pool of data. And it's specifically, let's say it's the red and the yellow account that I want to have access to this bucket. So we've been talking about this in right answer number 3. I can do that, no problem with bucket policy. In the year 2021, this is exactly how I would do this. I would say, let's do some read-write access from these other accounts. I would say the red account ID, the 12-digit account ID for them, the yellow account ID, and I would say they are allowed to read and write all of the objects in this bucket. This is what I'm trying to express, and it works. That's great. Now, like I mentioned a few minutes ago, ACLs were the original permission system on S3. They're still there until you disable them. So what are they? Well, they predate IAM, and they too are a sharing mechanism. The bucket ACL concerns actions that someone might take on the bucket. For example, list out its contents or put new content in there. The object ACL, each object has an ACL. So if I have a bucket with 1 trillion objects, each of those trillion objects has an object ACL, and each object ACL concerns actions that are taken directly on the object. For example, reading it. The ACLs also concern, further changes made to the ACLs, not really talking about that. Now, the thing to know about these ACLs, this has always been true ever since we've supported IAM in S3, which we have for quite a long time. Deny statements, this is why we did right answer number 3. Deny statements on your buckets, they work even if the permission was granted by way of an ACL. So deny statements, they work across the board. But these ACLs, they can do sharing beyond what it says in the bucket policy. And in a modern security approach, just to make auditability easier, it's best to have one place that you have to look at to figure out where your data is shared. So let's break that down. Let's go back to our scenario. I had this shared bucket of data. Red had some access, yellow had some access. They were both supposed to write some data. They were both supposed to read some data. And a scenario like this is possible, even common, right? ACLs have this notion of ownership. This is a little bit unique. If you're familiar with how IAM works across the rest of AWS, this part is unique to S3, and it's specifically because ACLs were part of the original storage for the Internet Charter of S3. When the red account writes an object, by default, unless it says something else, that object is owned by the red account, not by the blue account. Now, if you've never seen this before, that might actually be a little bit unexpected to you. The yellow account owns the things that it wrote. Now, of course, they can, and they probably do, grant full access to the blue account so that the blue account has full read and write access. But they own, by default, if you don't change anything about, your bucket that you've had for a long time, you might have objects that are owned by other accounts. Of course, the bucket policy is also in play with allow statements and deny statements working exactly the way you think. Now, there's a lot of colors in this picture. It looks kind of nice, but that does mean there's a lot of stuff going on here. And often our customers want to simplify this. Basically, they want the concept here to be that the blue account owns the bucket. The blue account should own everything in the bucket. And when you disable ACLs, when you take advantage of this new feature, this is exactly the picture that you get. Even if you've had this bucket for years and years and years, and red's been writing to it, and yellow's been writing it, and maybe long ago green was writing to it, so green owns some objects in there as well. And you've got thousands, you've got millions, you've got billions of objects in here. And you know exactly how you want to control access to them. Your policy says exactly what you intend to do. You can simplify this by disabling ACLs. When you disable ACLs, the effect of that, everything is now owned by the blue account. And furthermore, the great part of this, my favorite part of this feature, is now that this bucket policy tells you everything you need to know about how the data is accessible outside the account. There's nowhere else to look. Nothing else in the world can grant access to your data. This bucket policy says red and yellow have read and write access, and that's exactly what's going on here. And all the data they write is going to be owned by the blue account, all going to be governed by this policy. And that goes retroactive to all those objects you've had for all this time. So disabling ACLs. This is something we strongly recommend because I would really have a hard time thinking of anything that you could do with ACLs that you can't do better and more simply and more scalably with a bucket policy. So I recommend going back, disabling ACLs. If you know that you are relying on ACLs today, like I said, pretty much everything you're doing with ACLs can be translated into probably a simpler bucket policy. And then you can disable ACLs and have an easier management job from there on out. So in our API, you're going to see that this feature goes under the heading object ownership because technically it does concern who owns these objects. And the setting that you want, the disable ACL setting, is called bucket owner enforced. So we think you should do this. All right, that was 4 right answers. What do you need to take away from this talk? First of all, block public access. This is almost always the right answer for you. And like Meg said, when it's not, that's something you should move over to the side so that you can use block public access broadly over your whole environment. Step 2, we've made encryption easier to use and more cost optimized. And we have a number of options, just depending on what level of control you need over your encryption at rest. And the cool thing about server-side encryption is you don't need any crypto dancing client side. S3 does it all for you, so you get the benefits of crypto with really almost minimal or no work. Finally, bucket policies. Bucket policies are your focus for 2 things. First, bucket policies, once you've disabled ACLs, talk about that. Once you disable ACLs, bucket policies are the full story and where your data is shared, so that's where to write your sharing policy. And second, it's a great place to make assertions. Once you know exactly what shouldn't happen with your bucket policy, you can express that in deny statements, and those take effect no matter what else is going on there. And finally, we're really proud of this new feature to disable ACLs, and we think you should take advantage of it because everything you could do with ACLs, you could do better with a bucket policy. So, thank you so much for being here today. Thank you for coming. It's not lost on us that it is reInvent Friday, and you are here. So I think that means you are really interested in security in S3, so we thank you for that. Thank you very much. Now, 1 minute. So, all right. We really appreciate the staff that has made our in-person reInvent successful this year. I mean, I'm so happy to be back. And in order to just make their life easier, it's important to them to be able to clear the room pretty quickly after we go. Meg and I would love to take your Q&A. What we're going to do is we're going to head out of there and be in the hall, so you'll see us. If you have questions for us, just head out. We'll be right out there. And in fact, we have a number of other S3 people here with us. They're sitting in the back. I see you. They're going to help us. They're going to help us with the Q&A. So anything you want to ask us, come see us outside. And thank you so much for coming to reInvent.